Every line of physics you will ever write is a claim about the world. But a number on its own says nothing. The distance is 5 is meaningless until you say 5 what? Meters, kilometers, light years? Physics only becomes a science the moment we agree on a shared, reproducible language for measurement. This unit is the foundation course beneath the foundation. Mechanics, electricity, waves, quantum physics, none of it is trustworthy unless your quantities are precise, your units match, and your uncertainty is honestly reported. Examiners know this, which is why they weave these skills through every paper for the next 2 years. We begin with physical quantities. Before we can do any physics, we need to define what a quantity actually is. It is always a numerical magnitude multiplied by a unit. You will learn to sort every quantity you meet into base or derived and build the unit of an unfamiliar quantity from scratch. We will also look at how to make fast, order of magnitude estimates that examiners will accept in Paper 1. Next, we look at the International System of Units. All of physics rests on just 7 base SI units. You will learn to name them from memory and see how every other unit, the joule, the volt, the pascal, is built from them. You will use these base units to check if an equation is dimensionally consistent, catching errors before the examiner does. We will also lock down the standard prefixes from pico to giga, because fluent conversions are the cheapest marks on the syllabus. Then we tackle scalars and vectors. You will sharpen the distinction between scalar quantities, which have size only, and vectors, which have size and direction. This decides whether you simply add numbers or add arrows. You will learn to resolve any vector into 2 perpendicular components and combine several vectors into one resultant. This single toolkit is the silent engine behind projectiles, forces, and fields for the rest of the course. Finally, we confront the uncomfortable truth that no measurement is ever exact. Every reading you take carries an uncertainty, and a good physicist quotes it. You will distinguish systematic errors from random errors, and precision from accuracy. Most importantly for your practical papers, you will learn to calculate absolute and percentage uncertainties and propagate them through your equations. These are some of the most bankable marks in Paper 3 and Paper 5. Learn the rules, and you collect them every session. Get this unit right, and the rest of the course becomes a structured, self-checking discipline. In this unit, you will learn to express any physical quantity correctly, check complex equations using base SI units, resolve vectors without sign errors, and confidently propagate uncertainties through your practical data. Skip these basics, and you will lose easy marks on every single paper. Take your time here, master the fundamentals, and the rest of physics will follow.